PPT. Right. Good afternoon, students. So, last class we started vapor pressure of liquid in liquid we did. After that, vapor pressure of solid in liquid we did. No. Now see, this is the PPT evaporation, vapor pressure. We did all this. Now, right? And I am thinking so. I started ideal solution. Is it right? In ideal solution, we discussed positive deviation. We discussed, and I have to teach negative deviation. Correct? Right. Now see, open notes. Right heading. Negative deviation from Raoult's law. Last class we discussed what is ideal solution. After ideal I taught you non-ideal. In non-ideal we have two types, positive deviation and negative deviation. Now write heading negative deviation. Are you following, students? All of you write today's date, write heading negative deviation from Raoult's law. Right, negative deviation from Raoult's law. Now observe here, what is negative deviation? See, I taught you yesterday, assume liquid A is mixed with liquid B. I am mixing liquid A with liquid B. So after mixing liquid A with liquid B, interaction between AB becomes stronger. Are you getting my point? When I am mixing liquid A with liquid B, the liquid AB interaction comes stronger compared to pure liquid A and A. So right here, interaction between liquid AB will be how, student? Will be stronger compared to liquid A and liquid AB. So understood, after mixing A liquid with B liquid, interaction of AB comes stronger compared to liquid A and liquid B. Understood? Whereas in positive deviation, recollect those who are revising, in positive deviation after mixing A liquid with B liquid, AB interaction got weaker, we learned. Correct? Now see next, how should be shape, size and character? Do size, shape and character will vary or not? Then only it shows deviation. So write that size as well as what, student? Shape and character should how it should differ. So size should differ, shape should differ and character should differ. Then only it shows deviation. Correct. This is second point. Now tell me, I have added 50 ml of A liquid with 50 ml of B liquid. Actually, if there is no interaction, it should come 100. But here, see, since interactions are stronger, instead of getting 100, it comes 99.9. So why the volume is getting reduced? Interactions are becoming stronger, no? Getting idea, all of you? So what will be volume change of mixing? Volume change of mixing will be less than 0. Why? Since interactions are stronger. Since interaction of AB liquid is stronger compared to what? Stronger than AA liquid and BB liquid. Understood? So as interactions of AB is stronger, the volume is coming less than what? 100. Clear? Now tell me, student, how will be enthalpy change of mixing? You know enthalpy is what? Heat change accompanied. Do enthalpy change of mixing will be exothermic or endothermic? Since interaction of AB is stronger, so And what happens after forming AB liquid, interactions are stronger. So here it is what negative deviation, no? So heat gets evolved. Heat is evolved. Why interaction of AB becoming stronger? Because before forming AB, we are breaking the bond. Energy is what released. So what will be enthalpy change of mixing? Enthalpy change of mixing will be less than 0. Means heat is evolved. Why? Because AB interactions are stronger, whereas AA liquid, BB liquid are weaker. That means we are breaking the bonds A and BB bond easily. So breaking of bond is what? Endothermic, and formation of bond is what? Exothermic. So here heat is evolved. Why interaction of AB is stronger? Understood? So here heat is evolved. Negative. Delta H heat is evolved here. Means it is exothermic, no? Right. Now what will be entropy change of mixing? I told you yesterday whether it is ideal or non-ideal. The entropy change whenever we are mixing two liquids, randomness increases. Correct? So whether it is ideal or non-ideal, entropy change of mixing will be greater than 0. Up to this, copy it. Till this, copy. Understood all of you? This is what negative deviation we are discussing from Raoult's law. Clear, students? Any doubt in this? Right. Right. I'm going to next page. See, next we write enthalpy change, entropy change. Now tell me, student, how will be entropy change? Will it be positive or negative? Entropy change. Entropy, you remember in thermodynamics, entropy change of mixing will be greater than 0. That means it is spontaneous, no? Why? Because mixing of two liquid will be always randomness increases. This will be common. Now what will be Gibbs free energy change? Gibbs free energy also, will it be for the process to be spontaneous? How should be Gibbs free energy? It should be exothermic, negative, no? So it should be less than 0. These two will be common whether it is ideal or non-ideal. Understood? So in exam they give statements which of the following is correct about negative deviation. Now tell me, student, how will be partial prayer of A, that is experimental to that of theoretical? Partial prayer of A will be less than P naught of A into chi A. Understood? Why the partial prayer is coming less? Because interactions are stronger, no? So less tendency to convert it into vapor. Now how will be partial prayer of B liquid when we compare with Raoult's law? It will be less than P naught of B into chi B, because interactions are stronger. Getting idea? Then what will be the total vapor pressure of the solution? Total vapor pressure of solution also comes less than what? Raoult's law. That means less than P naught of A chi A plus P naught of B chi B. That means experimental pressure what we are getting, it is not equal to what? Theoretical. Why? Because there is deviation, no? Getting idea? So partial pressure of A will be less than P naught of A chi A, partial pressure of B will be less than P naught of B chi B. Total pressure of the solution also comes less than ideal. Clear up to here? Now write what are the examples for this. See, keep it in mind, students, one key point is there. In case of positive deviation, I told you where there is H bond breaking, it comes under positive deviation. Here keep it in mind, H bond formation. What is H bond? You know in first year, chemical bonding. If H bond formation is there, it comes what? It comes under negative deviation. So keep it in mind, hydrogen bond formation. You remember hydrogen bond arises between NOF. What are NOF? Nitrogen, oxygen, fluorine and hydrogen atom. Hydrogen bond arises between what and what, student? You know, no? Periodic table, nitrogen, oxygen, fluorine and hydrogen. Now see what are the examples I am taking. Acetone. You know what is the formula of acetone? Later in organic chemistry you study. This is acetone we call. Now see this acetone I am treating with chloroform. What is the formula of chloroform? CHCl3. CHCl3. Now see there is a hydrogen bond arrangement. Here hydrogen bond I am showing with dot. See there is H bond arising. This is H bond. So what happens? Interaction becomes stronger or not? Interactions between acetone, chloroform, interactions are becoming stronger. So keep it in mind where else H bond arises, their negative deviation. So in exam in that way also they ask which of the following shows negative deviation. See one example acetone with chloroform and second example I can take acetone with aniline. You know aniline later in organic chemistry you study acetone is CH3, COCH3, aniline you know what is the formula of aniline? C6H5NH2. Now there is hydrogen bond arrangement between oxygen and what? Hydrogen. See in between these two hydrogen bond arises. Acetone and what is the name of this compound? Aniline. You have to know the names. Aniline we call. Understood, right? Another example you take, another example H bond formation. Any strong acid dissolved in water. You know 6 acids are strong. Like HCl dissolved in water. Or nitric acid dissolved in water. See, keep it in mind, any stronger acid kept in water comes under negative deviation. Copy these. These are all examples which come under negative deviation. So in exam point of view, they ask you which of the following examples comes under negative deviation. Or in JEE means they can give set of molecule, number of set integer type. How many of them are showing negative deviation? So key point you remember where else H bond arises that comes under negative deviation. Understood, student, all of you? Now I share you the beginning of the negative deviation. See, this is what interaction of AB will be weaker compared to AA liquid and BB liquid. Size, shape should differ. Volume change of mixing will be 0. Enthalpy change of mixing will be 0. And entropy change of mixing should be greater than 0. Gibbs free energy should be less than 0. And external, that means experimental vapor pressure is not equal to theoretical. That means partial pressure of A will be less than Raoult and partial pressure of B will be less than Raoult and P total is also less than Raoult's law. And what are the examples you have to keep it in mind where there is H bond formation that comes under negative deviation like acetone, chloroform. What is the name of this? Chloroform. This is called chloroform. CHCl3, you remember chloroform we call. Later in organic chemistry we study. And this is acetone with aniline. Any strong acid dissolved in water, remember, if any strong acid is dissolved in water, that comes under negative deviation. Dear students, all of you understood? So with this ideal solution we learnt. Next non-ideal. In non-ideal we have two types, positive deviation and negative deviation. Now next we have to draw the graph for this. Copied all of you up to here. Now let us draw the graph. See how will be the graph. Previously we drawn graph for positive deviation. Now see, draw this graph, two extremes you draw. On the y-axis you take vapor pressure, here you take mole fraction. If this chi A value is 1, this chi B value will be 0. When we go this extreme, chi A comes to be 0, chi B comes to be 1. Now if this is P naught of A, that is partial pressure of A component, it slowly decreases with decrease in mole fraction. If this is P naught of B, this mole fraction of B get decreases. Now what I am showing is ideal, student. And this will give total vapor pressure of the solution. Linear sum we load, no, this is total pressure. This is partial pressure of A liquid, this is partial pressure of B liquid, this will be P total. Now this is what we drawn is ideal, dotted is ideal. Now deviation, how I show, see, deviation is shown negative, no? Now negative deviation, see, the graph is coming like this, below the line, see. This is negative deviation. Yellow line indicates deviation. So in exam graphical approach also they ask which of the following graph shows negative deviation. See, this is negative deviation from Raoult's law. Understood, students? So with this ideal we did, non-ideal positive deviation we did, and negative deviation we did. Clear for all? Copy this diagram. Next we go into azeotropic mixture. This dotted line is ideal amount. Thickened line is the deviation. We want to make a note that this dotted line is ideal. Dotted is ideal. Thickened is deviation. Negative deviation. Here, this is water, ideal and non-ideal. Now, beside next heading, azeotropic mixture. Now, this is important. See, in exam, they are asking azeotropic mixture. Now, observe here. What is azeotropic mixture? Important, student. In exam, they are asking questions on this. Azeotropic mixture is called constant boiling mixture. What is the name given to this? Azeotropic mixture is called constant boiling mixture. We call it as constant boiling mixture. Now what is observed here, all of you listen carefully. Now this azeotrope is a constant boiling mixture having definite composition. It will have a fixed composition, and whose composition in liquid phase, what the composition in liquid phase it is having, the same composition it will have in what, vapor phase. Getting idea? So azeotrope is a constant boiling mixture. Its composition in liquid phase, vapor phase will remain same, and it exists as a pure liquid, so we cannot separate them by distillation. At a particular point, what happens, what the composition in liquid phase it is having, the same composition it will have in what phase, vapor phase, and we cannot separate them by what, distillation. Such mixture is called azeotropic mixture. So I write definition here, understand the statement. What is constant azeotropic mixture? Here I am writing, see, it is a constant boiling mixture. It is a constant boiling mixture having definite proportion. Having definite proportion means it will have some fixed proportion. Having definite composition, we say. Definite proportion or composition. Fixed composition it will have. And its concentration, and so having a definite composition, and it has same composition in liquid phase and vapor phase. It is a constant boiling mixture. It is a constant boiling mixture having definite composition and a same composition in what phase and what phase? Liquid phase, what the composition is having, the same composition will be there in what? Vapor phase. And it has same composition in liquid and vapor phase. And behaves as a pure liquid. And this azeotropic mixture behaves as water, pure liquid, and we cannot separate them by distillation. And behaves as a pure liquid which cannot be separated by distillation. which cannot be separated by distillation. Why we cannot separate that composition? Because both the composition in liquid phase and vapor phase is remaining same, no? So they behave as a pure liquid, so we cannot separate them by, it cannot be separated by distillation. And such mixture we are calling what? Azeotropic mixture. So understood what is azeotropic mixture means? It is a constant boiling mixture. It is a constant boiling mixture. That means both the liquid will come out at a time. So both the composition of the liquid will come at a time. Why? Because its composition in liquid and vapor phase is remaining same. So it behaves as a pure liquid and we cannot separate them both liquids by water. Distillation, such composition is called azeotropic mixture. Understood, students, all of you? So this is important in exam. They ask what is an azeotrope mixture. So this understood, copied everyone. Now see, we studied two types of deviation. No? What are the two? Positive deviation and negative deviation. Now see, positive deviation, the liquid that is showing positive deviation from Raoult's law will form minimum boiling azeotrope. What is that? We will discuss. And the liquid that is showing negative deviation from Raoult's law, the one that is liquid showing negative will form maximum boiling azeotrope. So this azeotropic mixture, we divide them into two categories. What are those? Minimum boiling azeotrope, maximum boiling azeotrope. What is that? We will discuss one by one. So the one that is showing positive deviation will form minimum boiling and negative deviation will form maximum boiling azeotrope. Copy this up to this, and now we discuss the types of azeotropic mixture. Following friends, concept understood. So azeotrope is nothing but constant boiling mixture. Shall I continue? Now see next slide. Types of azeotropic mixture. Next our discussion is what are the types of azeotropic mixture. Now in this we have in our syllabus two types of azeotropic mixture we have. One is minimum boiling azeotrope. Now understand what is this minimum boiling azeotrope. Important in exam point of view. See, one I am writing minimum. Minimum boiling azeotrope. Why do we call minimum? We will discuss. Minimum boiling azeotrope. And what is the second category? Maximum boiling azeotrope. The second one is maximum boiling azeotrope. Now let us discuss one by one. Now why do we call minimum boiling azeotrope? Now see, which liquid will show minimum boiling azeotrope means the liquid that show positive deviation from Raoult's law. You remember in the example we took H bond breaking, I told you. Ethyl alcohol mixed with water. Water will disrupt the bonds in ethyl alcohol. So you remember ethyl alcohol mixed with water comes under the example of what deviation, students? Ethyl alcohol mixed with water we took under positive deviation, no? So this will come under positive deviation. That means the liquid that is showing positive deviation from Raoult's law will form minimum boiling azeotrope. Now what is that? See, understand. I told you in a fixed composition it will have an azeotrope. See, what is the fixed composition? This is having 95.5% ethyl alcohol. So azeotropic mixture has a definite composition we studied, no? And what will be the percentage of this? 4.5% ethyl alcohol. This together will form what? Azeotropic mixture. Now see, these two liquids will boil. Both the liquids will come out at a time. Why? Because they are composition in liquid and vapor phase is same, no? So see, for example, why we are calling minimum boiling azeotrope? For example, you see this boiling point is 78 degrees Celsius. What is the boiling point of ethyl alcohol? 78. And water, you know, water boils at 100 degrees centigrade. No, individual boiling point I am taking. Getting idea? Ethyl alcohol is 78 degrees centigrade, water is having 100. But these two components will come out below either of the 78 and 100 degrees centigrade. That means these two liquids will come below the temperature of boiling point of either 78 or 100. Means, are you getting my point? These two liquid mixture will come out at a temperature below than 78 and 100. That's the reason we are calling what? Minimum boiling azeotrope. Understood, students? So why we are calling minimum boiling? The two liquids will distill. Both the liquids will come out. We cannot separate ethyl alcohol and water separately at this composition. Why? Because the composition of both the liquids are coming same. So hence these two liquids will come out either of the both the temperature. They may come below 78 and below 100 degrees centigrade. That is we are calling as minimum boiling azeotrope. Now for that, see how I am drawing a graph. See, for this graph I am showing here. See, I am plotting a graph between vapor pressure on the y-axis, mole fraction of, here I am taking ethyl alcohol, and here I am taking mole fraction of water. Getting idea all of you students? Now see how this azeotropic mixture is forming. This I am showing with, see, this is vapor phase. This dotted line indicates vapor phase, and see this is another vapor phase. This is thickened line is liquid phase. This at this point what happens is both the liquids are coming out at what is the composition? 95.5% ethyl alcohol and 4.5% of what? Water. Both the liquids are coming out at a time, and see the temperature of this is 351.3 Kelvin. Means I am converting this 78 into Kelvin. 351.3 Kelvin, and the boiling point of water is 373 Kelvin. But this is what phase, student? This is vapor phase. Dotted line is what? Vapor phase. See, are you getting my point? This is vapor phase and this is what? A liquid phase. That means at this point what happens? See, at this point both the composition will be same. And what is that composition? You have to remember 95.5%, 4.5. But the temperature is coming here, see, 351.1. Now see, is the temperature boiling point is either lower than either of the two liquids or not? That's the reason we are calling it as water minimum boiling azeotrope. Concept understood all of you? So why do we call positive deviation as minimum boiling azeotrope? Means the both the mixtures are coming out either of the boiling point of 78 and 351.3 Kelvin. And so this graph, this is for what deviation? Minimum boiling azeotrope. Clear for all? And next I will explain you what is maximum boiling azeotrope, to whom we call maximum boiling azeotrope. So there you make a note, composition you have to remember. This is the composition for ethyl alcohol and water. There you write here in minimum boiling azeotrope, it is shown by positive deviation. Who will show minimum boiling azeotrope? It is shown by liquids showing what deviation, students? Positive deviation. Positive deviation from Raoult's law. And so this composition, after that draw this graph. This dotted indicates what? Vapor phase. See, till this point we cannot separate. At this point, as this point approaches, what happens? Both the liquid will distill at a time. And that mixture we are calling what? Azeotropic mixture. And boiling point here 351.3, here it is coming, say 351.1. That means both the liquids are distilling below either of the two boiling points. This is water boiling point 373. This is ethyl alcohol boiling point 351.3. And both the liquids, you show that both are coming out at 351.1 Kelvin. And so this percentage, this is the percentage of azeotropic mixture. There are the following students. So this is minimum. So minimum boiling azeotrope is shown by liquid showing positive deviation. Completed all of you. Now shall I start with maximum boiling? Right, next heading, maximum boiling azeotrope. Now see student, maximum boiling azeotrope who will show means liquids that are showing negative deviation from Raoult's law. So I write it in next page. So if you have done this, I move in next page. Next write negative deviation, maximum boiling azeotrope. Now observe here all of you, maximum boiling azeotrope. So why we are calling maximum? Because see, the liquids that are showing negative deviation from Raoult's law will show maximum boiling azeotrope. Liquids showing negative deviation from Raoult's law. Now here also what we take, I told you key point, which one will behave as negative deviation is, keep it in mind, where there is H bond forming. Example, I told you strong acid mixed with water. Now see, I am taking example of HCl. HCl mixed with water. See, this comes under negative deviation now students. Any acid, strong acid mixed with water. Here see, this percentage comes to 20% students, and this percent is coming 80%. Composition of these two comes as azeotrope. Now see, when we plot a graph between what versus what, observe carefully. I am plotting on the y here vapor pair, here mole fraction. Here on the x-axis I am taking mole fraction of HCl. This is mole fraction of HCl, and when I come to this corner, this is mole fraction of water. Now see how the graph will be. The graph will be like this. See carefully. This dotted indicates water, vapor phase. Dotted line indicates vapor phase. Second line indicates water, liquid phase. Now this point, see where is that point coinciding? Both the composition in liquid phase and vapor phase is same. At this composition, see, we get 80% of water, and see 20% of HCl we are getting, and this is called azeotropic mixture. And the liquid, both the liquid will boil either than the boiling point higher than the both the liquids. See how the boiling point of HCl when I take it is 188 Kelvin, and water boils at where student 373 Kelvin, and the boiling point of this is higher than this. See, it is coming at 381 Kelvin. See, is that both the liquids are distilling higher than either of the two liquids or not? That's the reason we are calling it as what? Maximum boiling azeotrope. Understood my point, what I am saying? So both these distills at a temperature higher than either of the two liquids in the pure state. This is having 188 Kelvin and this is having almost 373 Kelvin. But the liquids are both coming out at what temperature higher than either of the two liquids? No. And it is having a fixed proportion. What is that fixed proportion? 80% water, 20% HCl, and since it is negative deviation, a negative deviation will form what? Maximum boiling azeotrope. So understood. Now here you write liquid showing negative deviation will form maximum boiling azeotrope. Will show maximum boiling azeotrope. And in NCRT, if you remember nitric acid, in NCRT they have given composition nitric acid HCl. Can I take that also under negative deviation or not, students? So 63% nitric acid and rest of the percent means how much? 100 minus 63. So how much it comes from? 27%. 9 minus 6, 20, 10 minus 37, 9 minus 37% of this water comes the water. These two composition comes under water, maximum boiling azeotrope. 63% of nitric acid and 37% of water. Will also form what? Any acid mixed with water comes under what? Negative deviation, no? But in NCRT composition also you have to remember 63% of nitric acid and 37. Whereas in case of water HCl, 80% HCl and 80% water, 20% HCl will form maximum boiling azeotrope. Clear all of you? So simple, no? Till now what we learned, what is ideal solution and what is non-ideal solution. In non-ideal we learned what is positive deviation, what is negative deviation, and next I taught you azeotropic mixture. In azeotropic, two types of azeotrope, maximum boiling azeotrope, minimum boiling azeotrope. Minimum boiling azeotrope is shown by positive deviation, maximum boiling azeotrope is shown by negative deviation. Clear, students? All this is conceptual. In exam they can ask in conceptual questions or by giving statement wise. Clear? Copied and show this diagram. This dotted indicates what, students? Vapor form. This thicker is what? A liquid phase. Now I show you the PPT till now what we learned. Once copied all of this. Okay. Now factors affecting rate of evaporation we did in the previous class. And I told you graph at the point of equilibrium, rate of evaporation will be equal to rate of condensation. This is at equilibrium stage. Now properties of vapor pressure. What happens to if we increase the external pressure, then what will be the effect of vapor pressure? Vapor pressure, what happens? Inversely proportional. Now see factors affecting vapor pressure, nature of liquid, temperature. We discussed this volatile substance, non-volatile substance. And see a numerical on vapor pressure of benzene, toluene, xylene from Raoult's law this is. Now this is Raoult's law. See, previously we learnt vapor pressure of solid in liquid. The vapor pressure of an ideal solution of a non-volatile solute, see non-volatile solute, is equal to vapor pressure of the pure solvent. It depends only on the solvent at a temperature multiplied by its mole fraction. This is the relation, student. We wrote vapor pressure of solution is equal to P naught into chi. Next, the vapor pressure of solution containing non-volatile solute. Solution containing miscible liquid. This we discussed Raoult's law. And a problem we given this one. See mole fraction in gas phase. This is from Dalton's law. I told you no. Partial pressure is equal to P total into Ya. Composition in Ya. How we get Ya is equal to, this you have to apply Raoult's law. P naught of A into chi A by P total. The same relation here we wrote. Getting ideas, students? All this we discussed. Mole fraction of liquid phase. This we did. This is the problem related. Now see types of solution, ideal solution. So ideal solution we did, and this I taught you what is ideal, positive deviation, negative deviation. Now non-ideal solution, or we also call it as real solution. And see, is it visible to you? Is it clear? It might be blurred. This is in ideal they obey Raoult's law, they do not obey Raoult's law. Enthalpy of solution is not clear. Okay, so we'll leave this one. And now can you tell answers for this? Tell answers for this, write it fast, last 5 minutes. When alcohol is mixed with water, which type of behavior it is shown? Ethyl alcohol with water, students. What happens? H bond breaking, no? So it comes under positive deviation. Positive deviation from Raoult's law. Getting idea all of you? Ethyl alcohol mixed with water. Correct. Now tell me, acetone and chloroform. What is the formula of acetone? See, H bond involvement. I told you key point. This is acetone. Later in organic chemistry study, chloroform. What is the formula of chloroform? CHCl3. See, CHCl3 is called chloroform. You remember in chemical bonding 11th class, hydrogen bond arises between a highly electronegative atom and hydrogen. So what happens in negative deviation? Interaction of AB becomes stronger. This is A liquid, B liquid. After H bonding, interaction becomes stronger. So this will show what deviation, student? Negative deviation from Raoult's law. Getting idea all of you? Negative deviation from Raoult's equation. H bond involvement, any compound. Clear? Yeah. Now see, P naught of A is greater than P naught of B. Yesterday I told you the liquid that is more volatile will be more richer. I told you. If you remember Kono-Wolof rule. What is that rule we discussed? Kono-Wolof. Kono-Wolof. What Kono-Wolof said? A liquid that is more volatile. See here he is saying P naught of A is greater than P naught of B is saying. That means who is more volatile, student? A is more volatile, no? The one that is more volatile will be more rich in what? Vapor phase. That means Y of A should be more compared to what, student? Y of B. That means see in the option Ya. Ya is having more compared in liquid phase. When you are taking in liquid phase, this is Xa is the liquid phase, Ya is in vapor phase. So it should be A. Understood? Why composition of Ya is richer? Because this P naught of A is more volatile, no? That will be more in vapor phase compared with what? A liquid phase. According to what? Kono-Wolof. Do you remember last class I told you? A liquid that is having more vapor phase will be more richer in vapor phase. Are you following all of it? Right. Now see, aqueous solution of methanol in water. Methanol. What is the formula of methanol? The aqua vapor prayer. Methanol is CH3OH mixed with water. This will show what deviation, student? Positive deviation. No? This will show positive deviation from Raoult's law because H bond breaking. The aqueous solution of methanol in water has vapor prayer. This is positive deviation means it should be more than that of water or less than that of water, less than that of methanol, less than that of water is saying. So it should be what? Vapor prayer. When you are comparing methanol, this is positive deviation, no? It should be more than that of water. Where aqueous solution of methanol and water will show positive deviation. Positive deviation means interaction of AB becomes weaker compared to A liquid and BB liquid. So interactions are becoming weaker means it is having more volatile. Now this is considered binary solution of volatile liquid Xa. 0.4 vapor prayer is given. Now tell me in this considered binary mixture 2 volatile liquid Xa 0.4 Ya 580 torr mixture could be. So what type of deviation it is we have to find out in this. See, let us see azeotropic mixture. Now see azeotropic mixture is what? It is a liquid mixture having constant boiling point and vapor composition is same as that of liquid composition. The components cannot be separated by distillation. For this point, azeotropic mixture has constant boiling point. Vapor prayer, so we cannot separate them by distillation itself. The same thing now we discussed. And see next point, types of azeotrope. So this is what the graph you can see. This graph is this one comes under. This is what he has taken boiling point of water and boiling point of formic acid. And this he has taken a mixture of azeotrope. This is vapor phase, not that clear. Negative deviation and positive deviation. This comes under azeotrope. It's not that much clear. See, I show you how the components of azeotrope mixture can be separated from each other. We separate them by distillation means we cannot separate them because azeotropes cannot be separated. Now see, is azeotrope can be separated by fractional distillation means no, we cannot separate because composition will remain same. This is a numerical given in this DPP. This questions you have to do for homework only. Make a note in the module. If you have module with you, question number 1, 2, 3, 4, DPP 1, DPP 2. Daily practice, that is daily practice sheet. It will be in that. Make a note 1, 2, 3, 4, 2, 5, 7, 10 for homework. Module page number given 21, 22. In the question number 1, 2, 3, 4 you have to solve and 7, 9, 15. From the concept of till now what we discussed, till azeotropic mixture. In the next class we start colligative properties. Clear? So this make a note DPP, try to solve this question 1, 2, 3, 4 from DPP 1 and DPP 2, 2, 5, 7, 10. DPP daily practice sheet it will be and exercise question C. page number 21, 1, 2, 3, 4. Make a note, question number, page number given. And page number 22, 7, 9, 15, you try to solve this question for homework. So with this PPT 1 done, next class we start with colligative properties. So I am ending the session. Wish you all the best. So try to solve this question. Okay, bye.